Okay, so this is how to process the JMRUI software. So this is based at the MR Centre at Newcastle Hospital, Newcastle University. I'd like to thank Kieran Hollingworth for teaching me how to do this, Dr. Kieran Hollingworth. So first of all, you need to go to your the location where the file is located. So let us say I'm going to do it on GH32. So that's where my files are. But what you need to do first is to go to JMRUI, click it on, switch it on. Now the first thing to do is to go to options, close that, and set it up, set up options. Make sure your files are in the right place. So I want to do it on 32, so I'm going to go up, I'm going to look for my file, that's the one I want, select that, and then I'm going to copy that, and then paste it here, and then OK that. So now when I click on this button, and then you click on this button, you can automatically open that file. So the first file I want is this exercise 1, the SDAT file. This is a data file. I'm going to load this up. It takes a few minutes to load. You can look at this phase. It can show you the spectroscopy results, this, and then the fall in the PCR with the exercise, and then the recovery post-exercise. You can see that there. So the first thing you want to do is quantify that using the MRS. You want to load the information, the exercise information. This is exercise 1, as I said. So you load startingly. You want to load prior knowledge. Exercise again. You can see the rest option. That's for the rest exercise. Well, the rest phase of it. So here, there you go. Now you want to quantify this. Takes a few minutes to do. There's a lot of data there, 63 seconds of exercise. So now that says it's done, but I would just wait for a few more seconds. Now, and close this. Then you go to options, click on calculate pH. You can see that pH is calculated from the distance between the PI and the PCR, which is peak is 1. PCR peak is 2. You want to, this distance is the pH. So what you're going to do is put in 2 there. OK that. So that's now calculated. You can see a pH is here. That's present for all the different exercises. Well, the same exercise as 63 seconds of exercise, or 63 minutes of exercise rather. You want to save all as text, and you want to save it in the same folder. So you just click save there. That's done. It takes a few seconds, probably minutes, a minute or two to save that. So that's exercise 1. This is the 20% of maximum voluntary contraction exercise, the exercise where you're really looking at PCR depletion and then recovery. The next one is 30% MVC, where you're looking at the anaerobic process. You're looking at how pH, how low the pH falls in that one particularly. But we'll do that. So I'm closing. Right. So that's done now. The next step is go to exercise 1. Scroll up. Now you are looking at the PCR evolution, which means basically it's a temporal relation of a PCR with the exercise. You can see here how the PCRs are at baseline. Maybe here you can see that there's a PCR recovery. It's stepwise here, and then goes back to baseline here. So I'd probably say that this is a point of exercise. This is a point where the exercise starts over here. You need to be able to draw 3 lines through that like that. So this would be about 60 seconds, because that's 80, that's 100, 60 seconds. So I then scroll up, make sure the time, here you can see this, start time of exercise, I'd probably put it as 60, and then I got this time of recovery, and I probably put it as 140, as maybe 140. We can always change it and see if it doesn't fit the curve properly. And then I go to input 2, and here you see, now this is a bit more messier. You can see that the baseline here of the PC, and then it suddenly drops down there, and then it goes up a bit here. I don't know, I'll probably say this is 80. I probably need to check this with Kieran. And then this is a point of exercise recovery, which is 2. This is T. Okay. Now you can go to process A1. Yeah. Oh. And look at the goodness of the fit. And for that, you first want data, and you want to solve it. See, it's not fitting very well, and we can go back and have a look at it. Let's have a look here. Solve it. Again, this doesn't solve very well here as well. You see this this line here goes up. It just doesn't fit the curve very well. This probably will solve well. Yep, that looks good. Let's try that one. Solve. Let's say that's okay. Now, as you saw here, this didn't solve very well. This one or this one. So it's maybe there's a problem somewhere, and we could go back, have a look, input 1. It's probably okay, isn't it? Now the question is whether I use this point as a start of recovery 140, and maybe we could try and see if this is a point of recovery where you can draw a line through that. So if I said 230, what will happen? Go back. See if we can solve it now. There you go. You see that that's a much better solve there. Let's go have a look at this properly. See what this does. Even this is a better solve, but we can, yeah, this is a better solve than the one before. And there you go, these are fine. Now the results of the answers are in the sum output 1 and 2. So you've got exercise 1 here, exercise 2 here, and you've got the results here like PI, PCR, your PCR below basal, your percentage BCR drop, your tau half of the PCR, your tau half of the ADP, resting pH, end exercise and minimum pH, the nadir pH. You can also calculate the pH recovery time, which I will show in a later slide. Thanks for watching. It's Akash Sinha signing out again.